We talked in an earlier lesson about distributed generation. As a reminder, this is when electricity is generated near the location where it's being used. We also talked about the fact that with some energy sources being used for generation being more intermittent, for example, the sun doesn't shine all the time and the wind doesn't blow at the optimal speed all the time, you know that a connection to the grid is still needed. Otherwise, these customers would not have electricity 24/7. Another reason the grid is still needed is because many users sell energy back to the utility. And for this, you need a grid connection.
They benefit in two ways. One is when their generation is not operating, obviously the grid is providing them power. But the grid also supplies them capacity for their storage. Essentially, they're storing energy on the system. And then they're using it when they have load and their generation is no longer on. So they get there's two benefits there for customers with solar generation.
Back in the 70s, there was a push by the government to increase penetration of rooftop solar. This is the genesis of net metering, which is an approach for charging customers with rooftop solar. This approach was designed to encourage adoption, and so it served to make rooftop solar more affordable through subsidies. Fast forward to today, and solar rooftop penetration is going strong. So the question is being asked, does it still need government subsidies to grow, or could and should this market be able to stand on its own? At the center of the debate is the fact that those who don't have solar are subsidizing those who do. Let's dig into this in more detail.
So for a residential customer that has some solar generation, the watt-hour meter runs forwards and backwards depending on whether or not the customer is using more load than the solar is producing, or when the sun isn't shining, or it runs backwards when the load at the house is not enough it's too much for not enough for the solar capacity that's coming into the system. So the meter runs both ways. So when the meter runs backwards, there's negative kilowatt hours, and then when it runs forward, there's positive kilowatt hours. So according to the Commission rules, customers can install a system up to about 120% of their annual kilowatt hours. So if a customer has one of these systems where it's designed and it actually produces 120% of their annual kilowatt hours, then the meter in large terms ran backwards 120% of the time. And so what happens then is the utility didn't get paid any money for the system that's being connected, and then has to pay the customer for the energy that was produced in the system.
Net metering is approached a little differently in every state. Usually, here's how it works. Customers with rooftop solar or other distributed generation get credit for the extra electricity they sell back to the grid. Utilities are generally required to buy this electricity at the full retail rate. Now, if that same utility were buying power on the open market from other utilities, they would pay wholesale rates. But net metering specifies that the utilities must buy the power at a retail rate or a premium rate from net metering customers. The net, it's more expensive. Also, all of the fixed costs of the poles, wires, meters, advanced technologies, and other infrastructure still has to get covered somewhere. So the bottom line is that the net metering customer doesn't pay for this stuff, but they use it. So who pays for it? Customers without distributed generation or rooftop solar.
So when you take a look at a bill and it says a service charge, it's all over the place. Well, what's included in that service charge? And then we start talking about residential customers as it relates around to the energy rate. And this is where we get into a lot of these conversations about net metering. What's the cost effectiveness? Who's paying for what? Are they paying for their full share or not?
Right now, there's a pretty heated discussion going on about the need to relook at net metering. At the heart of the discussion is how to ensure fair compensation for solar companies as well as utilities.
Then you turn the corner, evolution of technology. You come to the solar industry. You have the rooftop installations. They're using what is known as net metering. Net metering is you measure the amount of energy that's coming out of the home, you measure the amount of the energy that's being consumed by the home, and you get to net the two together. The problem is that the infrastructure that's still behind that, that's based off of the how much is everybody using at the same time, is still needed, is still being utilized, but because of that netting, it isn't necessarily being paid for. And so that's, once again, back to that debate that's raging across the country right now, and how do you really balance these factors and the benefits that come from the installations? What's going to happen? And we have, I think, still a number of years before we really know what the outcome of that debate is.
So the industry is changing. That puts pressure on the regulatory side. For the last 100 years, most of utility fixed costs have been recovered in variable rates. Because it worked, and because there was either consistent load or increasing load. With distributed generation, that turns it upside down, and the variable amount of usage or sales is declining for many utilities, which puts pressure on them to recover their fixed costs in different ways, and then that creates some backlash.
The cost of producing solar power has gone down since net metering was first rolled out. The original purpose was to incent market growth. With that in mind, state legislatures and utility regulatory commissions are looking at outdated net metering policies. The solar industry has countered, saying that the subsidies aren't material and that the prevalence of rooftop solar helps to alleviate the strain on electric grids during summer days when demand soars. What we do know is that increased penetration of distributed energy technologies, particularly solar, is creating a fundamental shift in the U.S. electricity system. And public policy must respond to this. Policy over the previous one-way street approach no longer suits this complex market.